And welcome to Technology Tap. I'm Professor J. Rod. In this episode, DHCP, the invisible handshake of the internet. Let's tap in. All right, welcome back to Technology Tap, where we keep tapping into technology. I'm your host, Professor J. Rod, and today we're diving into the protocol that quietly assigns every device an identity on the network, DHCP, or Dynamic Host Configuration Protocol. Every time you connect your laptop, your phone joins Wi-Fi, or your Xbox goes online, DHCP is silently at work, handing out IP addresses, gateways, and DNS settings so that everything just works. You never see it, you never touch it, but without DHCP, every new device would be like a car with no license plate, unable to move on the information highway. So let's pull back the curtains and take a deep, detailed journey through how DHCP works, why is it essential, and how to troubleshoot it like a pro. So let's first start off with the definition. DHCP, Dynamic Host Configuration Protocol, is a network service that automatically assigns IP address and other network configuration parameters, like subnet mask, default gateway, and DNS servers to devices on a network. It operates on the application layer or layer 7 of the OSI model and uses UDP port 67 on the server side and 68 on the client side. Without DHCP, every device will require manual static configuration, a nightmare in environments with hundreds or thousands of hosts. So this is the example that I like to give my students, right? You get invited to a party. Usually I pick one of the students. I tell one of the students, hey, you invited me to a party in your house, and I'm crazy enough to accept. And when I get there, I want to get on the internet, right? The two things that I need to get on the internet from the person is their username and password of the Wi-Fi. What I need on my device is the MAC address and an IP address. Well, how do I get the IP address? Right? This is where DHCP comes in. Right? DHCP is what handles that. So imagine a college campus. Each day, thousands of students connect their laptops and phones to Wi-Fi. DHCP dynamically assigns each device a unique IP and returns it to the pool when they disconnect, keeping the network efficient. DHCP evolved from BootP, or Bootstrap protocol, in the early 90s. BootP would assign IPs but require a manual entry for every MAC address. DHCP automated that process, adding leases and automatically renewals. Why does DHCP matter? It simplifies configuration for large networks, presents IP conflicts, enables portability for devices, roaming laptops, phones, IoT, and allows central management of IP address ranges called scopes. DHCP is the unsung hero of the network, consistently handing out digital address faster than any human could. Now, DHCP magic happens through a simple four-way handshake called DORA, short for discover, offer, request, acknowledge, right? So when I put in that username and password on my phone, this four-way handshake happens between my device and your device. So when a client first connects, it has no IP address. It sends a broadcast message saying, hey, any DHCP server out there, I need an address. This message includes the client's MAC address, a random transaction ID, and optional parameters it wants like DNS or gateway. Right? This happens every time. DHCP then offers any available DHCP server that hears this broadcast responds with an offer, a unicast or broadcast packet containing a proposed IP address to your IP field, lease duration, subnet mask, gateway, or DNS options. So for example, here's an IP address 192.168.1.105 with a gateway of 192.168.1.1. The third step, the R in DORA, is the DHCP request. The client chooses one offer if multiple servers reply and broadcasts a request saying, yes, I'd like to accept the offer from 192.168.1.1. And then DHCP acknowledge the A in DORA. The server confirms an acknowledgement or ACK. It logs the lease in its database of binding the IP address to the client's MAC address for a defined time, the lease period, like apartment lease. It's leased like an apartment lease. Results, the client now has a valid IP, subnet, mask, gateway, and DNS, and is fully online. And that's how quickly it happens, right? It happens really quick. So when you join a coffee shop, Wi-Fi, your phone broadcasts a discover, the cafe router replies with an offer, your phone requests that address, and the router acknowledges, assigning you an IP from its pool. Within milliseconds, you are online sipping lattes and streaming podcasts, like Technology Tap. Each DHCP lease includes an expiration time, typically measured in hours or days. So let's break down how the lease are managed. Lease stages. 1. Bound. The client has an active lease. 2. Renewal. At 50% of the lease time, the client unicasts a request to renew. Rebinding. At 87.5% of the lease, the client broadcasts a new request if no reply was received. And expires. If the lease fully expires, the client releases the IP and must start DORA again. So the example, again, that I like to give to the students about the lease cycle is we're in the party, we're having a good time. Then we run out of soda and you ask me, hey, professor, can you go to the bodega and get a soda? Pepsi, Coke, Coca-Cola, Dr. Pepper. So I go to the bodega, right? Go to the bodega, go to the corner bodega, talk to the bodega guy, play with the bodega cat, because, there's always a bodega cat. Get the sodas, and then go back to the party. Now, my question is, do I have to re-log in again to your router, to your network, using the username and password you gave me? No. Am I going to have the same IP address that I had before I left to go to the bodega? Yes, I will have the same IP address. So here's another example. A 24-hour lease renews automatically after 12. If the server is down, the client tries again at 21 hours. And if still no replies, it releases and restarts DORA. Now, if a DHCP fails completely, Windows assign itself an APIPA address, which is in the range of it starts with 169.254.0.0. So it's anything between 169.254.0.0 and 169.254.255.255. This allows limited local communication, but no internet access. So if you see 169.254 whatever on your laptop, DHCP is either unavailable or it's been misconfigured. Then we have scope. Scope is a defined range of IP address that a DHCP server can hand out. So for example, you want to hold 0 through 99. You can start at 100. So you can say, hey, starting at 192.168.1.100 and 192.168.1.199, these are the IPs I want to give out. Exclusions address within the scope of that server that must not be assigned. Of course, the router, which is usually 192.168.1.1, right? Reservation, a permanent IP assignment linked to a device MAC address. You can do that too. That way, you put it in manually. It's static. It never changes. A printer, right? As an example, you might keep it the same, not change it. Router, servers, right? If you have a managed switch, you probably want to keep it the same. So in the small businesses, server and printers use reservations while users' laptop use dynamic. You don't need to put manually on the workstations. It makes no sense. Workstation doesn't really matter. right? You can put any IP on the workstations. It doesn't matter. So you let the DHCP do that. Printers, routers, servers, you want to do it manually. DHCP requests are broadcast, but they don't cross routers. In multiple VLAN environments, though, this is a problem. Clients in a VLAN 20 can't reach a DHCP server in a VLAN 10. So the solution, and we did this in my networking class this week, is a relay agent, usually a router, that forwards the DHCP request to the server on behalf of the client. It adds a key piece of info, the gig address or the gateway IP address field. GIADDR tells the DHCP server, and that's spelled GIADDR, which subnet the request originated from, so it knows which scope to use. So, example, if you have a VLAN 10, right, you want to use the router that starts with 10.10.10.1. If you have a VLAN 20, just for students, let's say, you want to start with 10.10.20.1. The server sees the GIADDR and assigns it from the right pool. If it's missing or wrong, clients may get the wrong subnet or no address at all. What are the DHCP security threats? 1. Rogue DHCP servers. Attackers plugging in an unauthorized router or laptop, handing out bogus IP address, gateways, or DNS servers. Results: traffic hijacking or denial of internet access. And I've seen this. Well, I haven't seen it that they did it, but not all DHCP servers are rogue, right? Like, well, I guess they can be. But I had one job where they brought in a wireless router and they plugged it into the network because the company was so cheap that they didn't want, everybody had wireless, but we did not. So they snuck in a wireless router and they hooked it onto the network. And nobody noticed that all the techs were bringing in their personal laptops to watch Netflix, right? That's when Netflix changed to streaming. Nobody realized that the techs, oh yeah, why is everybody bringing in their personal laptops to work? Nope, nobody knew. But it was because of that. I guess they must have configured it right. But if you could configure it wrong, that could give out IPs. Also, that wireless router. So, and you believe nobody got fired for that? And they only find out because they fired one of the guys. One of the guys got fired and he ratted everybody out. And he got fired. Well, allegedly, right? Allegedly ratted everybody out. Yeah, it was big news back then. All right, mitigation. Enable DHCP snooping on switches. It classifies ports as trusted or untrusted. Untrusted port can send DHCP requests, but not offers. DHCP starvation is threat number 2. Attackers flood fake DHCP requests using random MAC addresses, exhausting all available IP addresses. Legitimate clients can't connect. Use port security to limit MACs per port, rate limiting, and DHCP snooping with binding tables. And then data theft via rogue DNS. A rogue DHCP server can hand out malicious DNS settings, redirecting users to phishing sites. Always validate gateway and DNS info on suspicious networks. Advanced DHCP failover redundancies and options. Failover pairs. 2 servers share lease information modes. Hot standby, one active, one passive backup. And load balance, both active, 50-50 split. Split scopes, older method. 2 servers share one range, 80% on A, 20% on B. Used before formal failover protocols exist. DHCP options. DHCP can send additional configuration options. Gateway, DNS, domain names, network time, protocol server, TFTP, boot server and file, and VoIP for phones. DHCP version 6. IPv6 eliminates the need for NAT, and that's another network address translation. That's another podcast. That's for another podcast. But it will still require configuration automation. When is IPv6 coming? Who knows? I've been hearing it for 15 years. I suspect one big reason is money. And the other big reason is if everything is working, why do we need to change it? Because it's going to cost money. So the first reason is money, and the second reason is money, I think. we ran out of IPs a long time ago, and we developed this public-private addressing schema that's still working, right? And again, that's for another episode, right? I'll explain the public-private, and it's working. So yeah, we ran out of IPs, guys. We ran out of IP addresses years ago, and we're still using this method, and it's working. And I'm sure there's reasons to change it, but the main reason not to change it is money. So IPv6 will eliminate the need for all that. So there's two modes: the stateless address auto configuration, client self-assigned address from a router advertisement. No DHCP server will be needed. And DHCP version 6 stateful, server assigns IPv6 addresses and options like DNS and domain. They use port number 546 for the client and 547 for the server. And enterprise might use stateless address auto configuration for addressing, but DHCP version 6 for DNS, combining both methods. So, troubleshooting DHCP. Here's some symptoms and fixes. So if you have an IP address that's 169.254.x.x, that means DHCP is unavailable. Check relay, server, or cable. You would want to ask the person if it's just happening to you or it's happening to everybody else, because that's going to be a very important question to ask. Wrong subnet IPs, GIADDR is misconfigured. Correct helper address on the router or the server. Slow network joins, pull exhaustion, expand the scope or shorten the lease. Dedicated IPs, duplicate IPs, rogue server, enhanced DHCP snooping, and server not responding, UDP 67, port 67, 68 blocked, adjust firewalls. Now, one thing about DHCP, right? So let's get back to the party, right? So we're at the party, right? I go to the bodega, come back, I don't have to log in. But if I leave and this person is telling me, well, in 3 months or 4 months, I'm going to have another party and I want you to come. And when I go back, do I have to log in again? Or would it automatically log me in? What do you think? Well, the answer is depends. If they didn't change anything, i.e., get a new router, right? Configure, get a new username and password, I don't have to do anything. On my end, if I didn't get a new phone, right? If my phone is the same one, we should be fine. And I didn't restart it or reset it or reprogram it in any way, it should be fine in 3 months. Would I get the same IP address? Probably not. Probably not. So, because imagine, right? This is how it works. You have 2,000 people at a graduation ceremony at a college. 2,000 students are graduating. Each student brings in two devices, right? Average. So there's 4,000 IP addresses that they use. Once they graduate and they leave and they never come back, what happens to those IP addresses? Well, they get recalled because of the lease. They get recalled back, right? And then usually universities have it like a day. Some have 2, but it's usually a day. And at home, it's a couple of days, sometimes a week. It's depending on your ISP, how your ISP sets it up. You can actually change it if you go inside your router. Do you know how to go inside your router? If you don't know how to go inside your router, you open up a browser and you type 192.168.1.1, hit enter, and it'll pop up. Either 192.168.1.1 or 192.168.0.1. Now, some of them, you may get an error, like some kind of message. I'll bring mine up. It says your connection is not private, right? You may get that. When you type 192.168.1.1, it says your connection is not private. Just hit the advanced key, and then it's going to say the server cannot prove that 192.168.1.1, its security certificate is not trusted. Proceed, you hit proceed. It says unsafe. It'll say unsafe, but you proceed, you click it, and you should see your ISP. It should say, for Verizon, it will be log into network settings. So then you log in, and then you'll be able to get into your router. That's one way of doing it. So, all right. Another thing that I like to say about DHCP is, if you remember when we go back, if somebody calls you and they say, hey, I was able to log in, but I have no internet and no email. And, you see that they have a 169.254 IP address. You ask them if anybody else around them is having the same problem. If they are, then it's the server. Then you need to go to the DHCP server. You're probably going to need to reboot it. But if it's one person that's having this problem, I'm going to give you the answer, but I'm going to give you the interview answer, right? Rebooting will probably fix this issue, right? Once you reboot, the DORA will happen again, the four-way handshake, and they will get an IP address. Most likely, this will fix it. You say that in an interview, they're going to shake your hand, and they're going to tell you, thank you for coming, have a nice day. When you go on an interview and they ask you that question, you don't say, oh, I'll reboot the computer. No, even though rebooting is the right answer. It's weird. They want you to tell them how you would do it. And how you would do it is you will go into the command line and type ipconfig /release, hit enter, and ipconfig /renew. So what ipconfig /release does, it releases the IP address or any IP address that they have. And then the renew does the DORA, the four-way handshake. That is the answer that you give in an interview. You do not, you go into the command line and you do ipconfig /release, enter, and then ipconfig /renew. That does the four-way handshake. That does the DORA. That gets them an IP address. You should be fine. You should try it, but just letting you know, it's going to probably kick you off your network and then put you back on. But that's most likely, if you're applying for a help desk technician job, that's the answer that you have to give them. If you don't give them that answer, they will just give you a nice little handshake and they say, thank you for coming. Have a nice day. And this is also part of the A+ exam. CompTIA A+, they ask you, this question's always in there. In some iteration of it, it's in there somewhere. So, again, these are the things that you like to know. This is actually one of my favorite topics, DHCP, because you ask the student, well, how do you get an IP address? How do I get an IP address on my phone? How do I get an IP address on my computer? If I go to your house, how do I get an IP address? This is a process, right? It's not osmosis that it happens. There is something behind the scenes that happens when you hit, when you click it says username and password. Something happens when you hit enter, right? It's the DORA, it's the, the reservations, it's the lease, it's the scope, it's all this that it's involved in order for you to get an IP address. I find it fascinating that this is how it works, right? People think they know computers until they know computers. Until I bring this topic up and they tell me, oh, I never knew that. So DHCP is one of the oldest, yet one of the most critical services in modern networking. It gives life to every new device, allowing millions of endpoints to coexist smoothly. And it's not just about automation. It's about trust, reliability, and scalability. If you don't have DHCP now, why? You have to put everything manually, and you have to keep track of every IP that you use. If not, you're going to get duplicate IPs. And duplicate IPs is no bueno, right? You can't have two devices have the same IP and be on at the same time. That's not going to work. That would not work. So, all right. Let's see. Do I have questions? I do have questions. Let's do it. Which of the following correctly lists the DHCP message sequence? A, offer, discover, request, acknowledge. B, discover, offer, request, acknowledge. C, request, offer, discourage, acknowledge. Or D, discover, acknowledge, request, offer. I'll read it again. Which of the following correctly lists the DHCP message sequence, the four-way handshake? A, offer, discover, request, acknowledge. B, discover, offer, request, acknowledge. C, request, offer, discover, acknowledge. Or D, discover, acknowledge, request, and offer. Well, if you were listening to how I described it, it's DORA. So it's B, right? Discover, offer, request, acknowledgement. the 4-message handshake between the client and the server. Which network features prevents rogue DHCP servers from handing out address? A, dynamic ARP inspection, B, DHCP snooping, C, IP helper address, or D, radius authentication. Which network feature prevents rogue DHCP servers from handing out addresses? A, dynamic ARP inspection, B, DHCP snooping, C, IP helper address, or D, radius authentication. Well, the answer is B, DHCP snooping. DHCP snooping defines trusted versus untrusted ports and blocks DHCP server traffic from untrusted ports, stopping rogue servers. And again, one thing that I want to add about rogue servers, it could be like, you got to be really, really careful. Like, for example, those eros that Amazon sells, right? You have to configure them a certain way because those eros will give out IPs if you let it. You have to switch it to bridge mode. And if you switch it to bridge mode, then your router passes through those eros and give the IPs to the device. So, for example, if you have, the way I have it set up is I have like 100 feet cable coming out of the back of my router, one going upstairs, one going downstairs, and one going into the backyard. And they're connected to switches, which are then connected to eros, EEROS. Amazon sells them. So the eros, they give out the IP address. So I had to go in there and manually configure it to be bridged. So what happens is it takes the name of, I give it a wireless name, right? And then when, let's say, the TV plugs is looking for the internet, the smart TV, it attaches to the ERO. The ERO sends a message to the router saying, hey, I need an IP address. And then it sends it back to the ERO, and the ERO passes it to the TV. So I can get Wi-Fi upstairs, even though and then I get 300 meg wireless upstairs and downstairs and in the backyard because of the eros. And I have them connected to the switch. That helps. Connecting them to a switch helps. All right. Wow, that was a lot. This is, like I said before, DHCP is one of my favorite topics. I love teaching it because the students have never heard of it. So, all right, that's it. For me, I'm Professor J-Rod. Keep learning, stay connected, and keep tapping into technology. This has been a presentation of Little Cha-Cha Productions, art by Sarah, music by Joe Kim. We're now part of the Pod Match Network. You can follow me at TikTok at Professor J-Rod, that's J-R-O-D, or you can email me at ProfessorJrod, J-R-O-D, @gmail.com.